Recommendation of related search queries is a standard feature on many search engines and news applications. The conventional method relies on text matching to select search queries for recommendation. It has several limitations. For instance, you need to store a set of candidate queries. The performance of your system is dependent on and limited by the quality of your candidates. Also, a matching-based system would have limited coverage. For example, in Google, not every query would have recommendations, only those under popular topics. Therefore, we propose the use of deep generative models to tackle this task. First, we develop a strong understanding on the input query or document title. Then, we generate more related queries for recommendation word by word. Sequence-to-sequence is a popular generative model in the field of natural language processing. The most basic version is made up of an encoder RNN, a decoder RNN, and a feedforward plus softmax projection layer. In a large-scale application, such as generating a query for recommendation, we would have a large output vocabulary. However, this would create a problem in the feedforward layer. Specifically, model size and training time would increase dramatically with a large output vocabulary. And we cannot simply limit the vocabulary size because, with a small vocabulary, the model is more likely to produce out-of-vocabulary tokens, which of course would hurt the performance. In this work, we tackle these challenges by proposing a two-stage generative framework. In the first stage, the main idea is to predict what words might appear in the output. We call these relevant words. They constitute a dynamic vocabulary which contains different words for different inputs. In the second stage, we have a dual vocabulary sequence-to-sequence model. As the name suggests, it reads in the dynamic vocabulary from the first stage, and it also maintains a small static vocabulary of commonly used words. The output word is selected from one of these vocabularies. We utilize the click graph to discover relevant words for a query, also to find other queries to recommend. In Figure A, the highlighted queries form a one-hop symboling set, and the target relevant words for both queries are books, learning, Python, and recommended. Similarly, in Figure B, all three queries form a two-hop sibling set, and the target relevant words are all the non-stop words. Here's an overview of our framework. On the left, we have the relevant word generator, which contains a bidirectional gated recurrent unit and a projection layer. We take the top k predicted relevant words from a large output vocabulary and append them to the input. This will be our dynamic vocabulary, and it will be used by the sequence-to-sequence model on the right. The sequence-to-sequence model handles the dynamic vocabulary through an attentional relevant word selector module. To generate an output word, our sequence-to-sequence model produces three things: a probability distribution over the dynamic vocabulary, a probability distribution over the static vocabulary, and a single binary value representing the probability of selecting the next word from the dynamic vocabulary. In this work, we investigate two problems: generating queries for recommendation from an input query, and generating queries for recommendation from a document title. We collect 8 days of click data from the QQ mobile browser to build a large click graph. We then collect our training and testing data from this graph. Experimental results show that our framework outperforms all baselines on BLEU, Roach, and EM metrics. It also generated considerably less out-of-vocabulary tokens. This concludes our short intro. Thank you.